The conference room at the European Space Agency's headquarters in Paris fell silent as Dr. Elena Vasquez dimmed the lights. On the massive screen behind her, a cascade of data flickered, numbers, graphs, and images that seemed to defy every known law of physics. It was March 15th, 2025, and what she was about to reveal would shake the foundations of cosmology itself. "Ladies and gentlemen," she began, her voice steady despite the tremor in her hands, "we may have detected evidence of what existed before the Big Bang." The statement hung in the air like a physical presence. Around the table, representatives from NASA, the Chinese National Space Administration, and a dozen private research institutions leaned forward. Dr. James Chun from MIT broke the silence first. "That's impossible. By definition, there was no before the Big Bang. Time itself began at that moment." Dr. Vasquez smiled, but there was no joy in it, only the weight of knowledge that would change everything. "That's what we thought, until 3 months ago." It had started, as so many revolutionary discoveries do, with an anomaly. The James Webb Space Telescope, peering deeper into space and time than any instrument before it, had been conducting routine observations of the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space. But something was wrong with the data. Dr. Marcus Webb, a postdoctoral researcher at Cambridge, had been the first to notice the pattern. At 3:47 a.m. on December 8th, 2024, hunched over his third cup of coffee, he saw it. A series of temperature fluctuations in the CMB that shouldn't exist. They were too organized, too symmetrical, too deliberate. "At first, I thought it was instrument error," Marcus explained to the assembled scientists, his image transmitted via video link from England. "We recalibrated, ran diagnostics, checked every possible source of contamination, but the signal persisted. And then we realized it's not random noise. It's information." The implications were staggering. The cosmic microwave background was essentially a baby picture of the universe, taken when it was only 380,000 years old. Finding patterns in it that suggested pre-Big Bang phenomena was like discovering that a newborn baby had memories of events before its conception. Dr. Yuki Tanaka from JAXA, the Japanese Space Agency, pulled up additional data on her tablet. "We confirmed the findings with our Atomi 2 observatory. The patterns appear as subtle temperature variations. We're talking about differences of only a few millionths of a degree, but they're there and they're consistent across multiple observations. The patterns form what physicists were calling bruises in space-time. Regions where the fabric of reality itself seem to bear the scars of some pre-universal event. These weren't just random fluctuations. They appear to be the remnants of collisions between our universe and something else, something that existed before time began." The discovery ignited fierce debate across the global scientific community. Within days, 3 major theoretical camps had emerged, each with passionate advocates and compelling evidence. Professor Sarah O'Brien from Princeton led the charge for the cyclic universe theory. "What we're seeing is evidence of a previous universe," she argued during a hastily arranged symposium at CERN. "The Big Bang wasn't the beginning. It was a transition, a phoenix rising from the ashes of what came before. According to this model, the universe undergoes infinite cycles of expansion and contraction. Our Big Bang was actually a big bounce, the moment when a previous collapsing universe reached maximum density and rebounded into expansion, creating our current cosmos. The mathematics are elegant," O'Brien continued, displaying complex equations that fill multiple screens. "Every cycle lasts approximately 1 trillion years. The universe expands, driven by dark energy, until it reaches a maximum size. Then, through a process we're still working to understand, it begins to contract. Eventually, it collapses back to singularity, but instead of ending, it bounces. The bruises in the CMB, according to this theory, were gravitational echoes from the previous universe. Massive structures like superclusters of galaxies that were compressed during the Big Crunch and left their imprint on the geometry of space-time itself." Dr. Raj Patel from Oxford presented an equally compelling alternative. "We're not looking at the remains of a previous universe," he insisted. "We're seeing evidence of other universes that exist right now in higher dimensions." String theory had long predicted the existence of a multiverse, a vast cosmic landscape where countless universes bubble into existence like foam on the ocean of reality. Each universe is a membrane or brain, floating in higher dimensional space. What if, Patel proposed, the Big Bang was caused by a collision between two of these brains? Our universe and another crashed together 13.8 billion years ago. An enormous energy release in that collision is what we perceive as the Big Bang. The bruises in CMB would then be impact sites, places where the other universe literally crashed into ours, leaving permanent scars in the structure of space-time. Computer simulations supported this idea, showing how such collisions could produce temperature patterns remarkably similar to what the telescopes were detecting. Even more tantalizing, this theory suggested that we might be able to detect the other universe. If the collision had been recent enough in cosmic terms, perhaps we could observe gravitational waves or other signals from beyond our cosmic horizon. The third major theory came from an unexpected source. Dr. Lin Wei, a young theoretical physicist from Beijing who had published only 3 papers, presented a radically different interpretation at a conference in Singapore. "You're all thinking too classically," she told an audience of scientists who had decades more experience. At the moment of the Big Bang, quantum effects dominated. The universe wasn't a smooth, continuous thing. It was a seething foam of quantum fluctuations, where space and time themselves were probabilistic. According to quantum mechanics, at sufficiently small scales and high energies, the normal rules break down. Space and time become grainy, discontinuous, a quantum foam where virtual particles pop in and out of existence, and the very geometry of reality fluctuates wildly. Before the Big Bang, and I use that term loosely because before doesn't really apply, there was only quantum foam, Lin explained. No classical space-time, no causality as we understand it. The Big Bang was the moment when quantum gravity effects created a bubble of classical space-time within the foam. That bubble expanded and cooled, becoming our universe. The bruises in the CMB, in this view, were quantum fingerprints. Regions where the transition from quantum foam to classical space-time had been particularly violent, leaving permanent imprints in the structure of our universe. As theories multiplied, so did the demand for better data. Within weeks of the initial announcement, a coalition of space agencies and private companies announced the Deep Space Array Project, an ambitious plan to deploy a network of ultrasensitive detectors throughout the solar system. Dr. Vasquez was appointed project director. "We need to observe the cosmic microwave background from multiple vantage points," she explained at the project kickoff meeting. "By studying how these bruises appear from different locations, we can triangulate their 3-dimensional structure and hopefully determine which theory is correct." The project was unprecedented in scope. NASA would launch 3 spacecraft to the outer solar system. ESA would deploy 4 satellites in solar orbit, positioned at the points of a tetrahedron around the Sun. China's CNSA would contribute advanced quantum sensors, while private companies like SpaceX and Blue Origin would provide launch services and orbital infrastructure. The total cost, $47 billion. The timeline, 5 years to full deployment. The stakes, understanding the origin of everything. On June 3rd, 2025, everything changed again. Dr. Marcus Webb was the first to detect it, just as he had been first to spot the original bruises. At 2:14 a.m. Greenwich Mean Time, one of the preliminary Deep Space Array satellites picked up something extraordinary, a coherent signal embedded in the cosmic microwave background. "It's not natural," Marcus told Elena in an emergency video call, his eyes wide with a mixture of excitement and fear. "The frequency is too precise, the modulation too complex. Elena, I think it's artificial." The signal was impossibly faint, a whisper against the roar of the cosmic background. But it was there, oscillating in a pattern that bore no resemblance to any known natural process. When Marcus ran it through standard decoding algorithms, something even more shocking emerged: mathematical constants. Pi, Euler's number, the golden ratio, the fine structure constant, all embedded in a signal that had been traveling through space for 13.8 billion years, since the moment of the Big Bang itself. How is this possible? Elena breathed, staring at the data Marcus had sent. Who could have encoded this? And when? "That's not the strangest part," Marcus replied, his voice barely above a whisper. "I've been analyzing the signal structure. It's not coming from our universe. It's coming from whatever was there before." News of the signal leaked within 48 hours, despite desperate attempts to maintain secrecy. The response was immediate and global. Religious leaders across the world offered interpretations. Pope Francis called it a message from the divine architect. Buddhist scholars suggested it might be evidence of previous world cycles, as described in ancient texts. Atheist intellectuals argued it was simply proof of a pre-existing physical reality, with no supernatural implications necessary. The general public was fascinated and frightened in equal measure. Social media exploded with theories, memes, and wild speculation. Were we receiving a message from an advanced civilization that existed in the previous universe? Was it a warning? A greeting? Instructions for how to survive the next big crunch? Financial markets fluctuated wildly as investors tried to price in the implications of contact with a pre-universal intelligence. Technology stocks surged on speculation that the signal might contain advanced scientific knowledge. Religious-themed investments rose as millions sought meaning in ancient texts and traditions. Meanwhile, the scientific community was in turmoil. At universities worldwide, researchers abandoned other projects to focus on the signal. New papers appeared daily on AR-14, the physics preprint server, each proposing different interpretations and decoding schemes. By July 2025, a dedicated team of cryptographers, linguists, mathematicians, and physicists had assembled at CERN to coordinate the decoding effort. Dr. Vasquez led the team, which included some of the brightest minds on Earth. "We're not just decoding a signal," she told the assembled group at their first meeting. "We're trying to understand a message from an intelligence that existed before time itself, before our universe. We have no shared context, no common reference points. How do you communicate with something that literally predates existence?" The team worked in round-the-clock shifts, approaching the problem from every angle. Mathematicians searched for patterns in prime numbers and algebraic structures. Linguists applied principles from the search for extraterrestrial intelligence, looking for universal concepts that any advanced intelligence might share. Physicists analyzed the signal for embedded information about physical constants and natural laws. Dr. Kenji Yamamoto, a mathematician from Tokyo University, made the first major breakthrough. The signal isn't just containing mathematical constants, he announced during a team meeting in early August. It's using them as a coordinate system. Each constant defines a dimension in an abstract mathematical space. When you plot the signal in that space, he displayed his results. The team fell silent. In the multidimensional space defined by fundamental constants, the signal traced out a shape, a geometric structure of impossible complexity and perfect symmetry. It was beautiful, alien, and somehow deeply familiar. "It's a map," Dr. Vasquez whispered. "A map of something." Over the following weeks, more of the message's structure became clear. It wasn't a simple transmission of information. It was a multi-layered encoding that revealed different meanings at different levels of analysis. At the most basic level, it contained what appeared to be mathematical and physical formulae, equations that described physics beyond the standard model, including a complete theory of quantum gravity that had eluded Earth's physicists for over a century. At a deeper level, it contained something that looked like engineering diagrams, blueprints for technologies that seemed to manipulate space-time itself, along with instructions for building devices the team could barely comprehend. Wormhole generators, vacuum energy extractors, causality shifters. But the deepest level was the most profound. Embedded in the very structure of the signal was what Dr. Vasquez's team came to call the testimony, a narrative told not in words but in pure mathematical concepts, describing the end of the previous universe. According to the testimony, the previous universe had been ancient beyond comprehension, trillions of years old, far older than our current cosmos. It had been inhabited by civilizations of such advancement that they had effectively merged with the fundamental forces of nature, becoming beings of pure energy and information. These beings had watched as their universe entered its final phase, as dark energy tore apart the fabric of space-time and entropy reached its maximum. They knew their cosmos was ending, but they also knew that from a quantum foam that underlay reality, new universes could emerge. So they did something unprecedented. They encoded themselves, their knowledge, their history, their very existence, into the quantum fluctuations that would seed the next universe. When the Big Bang occurred, that information was imprinted into the cosmic microwave background, waiting for some future civilization to evolve the technology to detect and decode it. They made themselves immortal, Marcus said, staring at the decoded message in awe, not as physical beings, but as information. They survived the death of their entire universe by hiding themselves in the structure of ours. The discovery triggered intense ethical debates across the globe. Now that humanity knew how to decode the message, what should be done with the knowledge? The blueprints embedded in the signal described technologies that could revolutionize human civilization or destroy it. Unlimited clean energy, faster than light travel, the ability to manipulate space-time itself, but also weapons that could tear holes in reality and experiments that might destabilize the quantum vacuum, potentially destroying our universe just as the previous one had ended. We're children playing with the tools of gods, warned Dr. Zhou Ming, a Chinese physicist and member of the decoding team. We barely understand our own technology. What happens if we try to build devices based on physics that operated in a different universe, under different natural laws? Others argued that humanity had no choice but to pursue the knowledge. The signal is already out there, countered Professor O'Brien. Every civilization in our universe with sufficiently advanced technology will eventually detect it. If we don't develop these technologies, someone else will. The only question is whether humanity leads that development or falls behind. The United Nations hastily convened a special session to discuss governance of what was being called the pre-universal heritage. Should the decoded information be made public? Should its technological applications be restricted? Who had the authority to make such decisions on behalf of all humanity? Meanwhile, several nations had quietly begun their own independent decoding and development programs, refusing to submit to international oversight. The race to master pre-universal technology had begun, and not everyone was interested in playing by the rules. As scientists and engineers grappled with the practical implications of the discovery, philosophers and theologians confronted its deeper meaning. This changes everything, declared Dr. Thomas Brennan, a philosopher of science at Oxford. For centuries, cosmology has pushed toward the question of first causes. What caused the Big Bang? This discovery shows that question may be fundamentally misguided. There may be no first cause, just an infinite regress of universes, each giving birth to the next. The theological implications were equally profound. If our universe was seeded by information from a previous cosmos, what did that mean for concept of creation and divine purpose? Some religious thinkers saw it as confirmation of eternal cycles described in ancient texts. Others argued it was entirely compatible with theological cosmology. Perhaps God worked through these cosmic cycles, creating and recreating throughout eternity. Still others experienced what some commentators called an existential vertigo. If we were living in a universe that was essentially a message from the previous one, if our very atoms were shaped by information encoded by ancient beings, then what did that mean for concepts of free will and determinism? Are we really independent beings making free choices? Asked philosopher Dr. Amelia Rodriguez in a widely viewed interview. Or are we, in some sense, the thoughts of those pre-universal entities, still playing out the programs they encoded into the quantum substrate reality? By October 2025, teams around the world working with fragments of the decoded technology began reporting strange phenomena. At CERN, an experimental device based on pre-universal physics blueprints created a tiny region of space where causality seemed to flow backward. Effects preceded causes for fractions of a second within the device's field. The experiment was immediately shut down when researchers realized they couldn't predict or control what would happen if the effect expanded. In China, scientists testing a vacuum energy extractor detected what they described as echoes from outside space-time, brief bursts of data that seemed to come from other universes or other points in the cosmic cycle. The echoes contained fragments of what might have been communications, but in forms so alien that even the most advanced AI systems couldn't begin to translate them. Most disturbing were the reports from Australia, where a team at the Australian National University had built a quantum sensor based on pre-universal designs. The sensor was supposed to detect gravitational waves with unprecedented precision. Instead, it detected something else. "We're picking up patterns that suggest our universe isn't alone," reported Dr. Sarah Chun, the project lead. "There appear to be other universes adjacent to ours in higher dimensional space, and some of them are aware of us." The sensor had detected what could only be described as probes, ripples in higher dimensional space that seemed to be systematically exploring the boundary of our universe. Whether they were autonomous artifacts from previous cosmic cycles or something else entirely, no one could say. "It's like we discover we're living in a house," Dr. Chin said in a leaked recording from a classified briefing. "And we just realized there are other houses all around us, and some of them have lights on." In November 2025, Dr. Vasquez received a classified briefing that would change the trajectory of her life. Representatives from the U.S., European Union, China, and Russia presented a joint proposal, the Omega Project. "We need to build a detector array unlike anything attempted before," explained General Zhang Wei of the Chinese Strategic Support Force. "Not just to study the cosmic microwave background, but to actively probe the boundary of our universe and communicate with whatever lies beyond." The project would require resources on a scale rivaling the Apollo program or the Manhattan Project. Dozens of spacecraft deployed throughout the solar system and beyond. Quantum computers processing exabytes of data per second. And at the center of it all, a device that the pre-universal messages blueprints called a temporal resonator, a machine capable of sending information backward in time to the quantum foam that underlay reality. "If the previous universe could encode a message for us," the general continued, "perhaps we can send messages to the next. We can ensure that human knowledge, human culture, human consciousness survives the eventual heat death of our universe and persists into whatever comes after." Dr. Vasquez looked at the faces around the table. Scientists, military officers, politicians, all united by a vision that transcended national boundaries. They were proposing nothing less than humanity's first attempt at true immortality, not as individuals, but as a civilization. "How long do we have?" she asked. "The latest cosmological models suggest our universe has approximately 10 trillion years before heat death," replied Dr. Patel, who had been brought in as a consultant. "But the decoded message suggests there may be ways to accelerate certain processes, to trigger a new Big Bang sooner under controlled conditions, while preserving the maximum amount of information from our universe." The implications hung in the air. They weren't just talking about preparing for the far future. They were discussing the possibility of deliberately engineering the end of our universe and the beginning of the next. By the end of 2025, the world had fundamentally changed. The discovery of pre-universal information and the technologies it contained had altered human civilization in ways both subtle and profound. Space agencies around the world had quintupled their budgets. Private investment in advanced physics research had skyrocketed. Universities were graduating record numbers of physicists, mathematicians, and engineers, all eager to work on unraveling the mysteries encoded in the cosmic microwave background. But there was a darker side. Several rogue states had attempted to build pre-universal weapons, leading to tense standoffs and, in 2 cases, limited military interventions by international coalitions. Underground markets traded in stolen fragments of decoded technology, with prices for even partial blueprints reaching hundreds of millions of dollars. Religious movements had splintered and reformed around the new cosmology. Some embraced it as revelation, others rejected it as demonic deception. The Catholic Church had established a new theological commission to reconcile the discovery with church doctrine. Islamic scholars debated whether the pre-universal beings could be considered creators in any meaningful sense, or whether they were simply advanced creations of Allah working within his eternal design. Most powerfully, the discovery had given humanity a new sense of perspective. Looking up at the night sky, people now knew they were seeing not just distant stars and galaxies, but the remnants of a cosmic drama that had been playing out for far longer than anyone had imagined. A cycle of universes rising and falling, each carrying forward information from those that came before. On December 31st, 2025, as the world prepared to welcome a new year unlike any in human history, Dr. Marcus Webb was alone in his Cambridge laboratory, conducting routine analysis of the latest deep space array data. At 11:47 p.m., he detected something that made his blood run cold. The signal from the pre-universal beings wasn't complete. What they had decoded over the past months was only a fraction, perhaps as little as 1%, of the total information encoded in the cosmic microwave background. And the newly detected sections of the message seemed to contain something the initial decoding had missed. A warning. Marcus's hands shook as he ran the preliminary analysis. The warning was clear, unmistakable, encoded with redundancy to ensure it wouldn't be overlooked. The technology described in the message's blueprints wasn't just tools for studying and manipulating reality. It was a test. The pre-universal beings had faced a choice at the end of their cosmos, a choice about what to pass forward to future universes. They had encoded both the knowledge to transcend the cycle of cosmic birth and death, and the knowledge to remain part of it. The technology described in the message could do either, depending on how it was used. Use it wisely, and humanity could join an eternal community of consciousness that persisted across cosmic cycles, accumulating knowledge and experience without end. Use it foolishly, and humanity might trigger a premature collapse of the universe, or worse, create a quantum deadlock that would prevent any future universe from forming, bringing the entire cosmic cycle to a permanent end. "We have to tell them," Marcus whispered to the empty room, reaching for his phone to call Dr. Vasquez. "We have to tell everyone. The message isn't just information. It's a test we might already be failing." But even as he made the call, Marcus wondered, had the pre-universal beings anticipated this moment? Had they known that any civilization discovering their message would go through exactly this progression, from wonder to understanding to fear? And if they had known, what did their decision to encode the message anyway say about their judgment of humanity's future? As midnight struck and fireworks exploded across time zones around the globe, celebrating the arrival of 2026, the greatest mystery in human history remained unsolved. Not the mystery of what came before the Big Bang. That question, in its way, had been answered, but the far more pressing mystery of what would come after. What would humanity choose to do with the knowledge the pre-universal beings had left behind? The cosmic clock was ticking. In the grand scheme of things, humanity had just been born. But already, the choices it made in the coming years would echo through not just a lifetime of our universe, but perhaps through all the universes yet to come. In laboratories and observatories around the world, scientists continued their work, racing to decode more of the message before national rivalries or human folly destroyed the chance to learn from those who had come before. And in the night sky, the cosmic microwave background continued its gentle whisper, carrying secrets that spanned the gulf between one universe and the next, waiting patiently for those wise enough to listen and brave enough to understand. The story of what came before the Big Bang had been revealed. The story of what came next was still being written, one choice at a time, by 7 billion human authors who had just discovered they were part of something infinitely larger than themselves.